Hey there, everybody. Welcome back. We are going to finish up chapter 8.6. Here we're working with complex numbers. The standard form for complex numbers is A plus BI. A is considered the real part, and B is considered the imaginary part. Now, B can be something just like a whole number. It can be a radical or both. A better way of looking at this or thinking about this is A plus BI root C, but we don't do this. We don't do the generic form like this. But with actual numbers, it often looks like this. This is the form. We usually just call it A plus BI. I'm going to weigh that corner down. I got a fan blowing in here. It's making a little motion. When we simplify into standard form, there's one thing in particular we want to always do. Always remove the negative component from a radical first. I'll say part because that's shorter than component. Before operations or other stuff. And you'll see where this becomes important in one of our examples. We'll start with some basic ones first, though. Example, well, we can do addition and subtraction with these. Let's say we've got our first complex number is -5 plus 3i, and our second complex number is 2 minus 6i, and we're adding these two together. So with adding or subtracting, the reals go together and the imaginaries go together. This is -5 plus 2, and then I've got 3i minus 6i. Now, normally you don't need to write this, you would just combine them, but I wanted to show what I was doing. This becomes -3 minus 3i. Okay. All right, why don't you guys give one a try? Let's throw in subtraction. We'll do a -11 minus 8i, then minus our second complex number. It's going to be 2 plus 12i. Go ahead and pause the video and try to solve that or simplify that. I'm going to break this up into two parts, the -11 and then -2. And then I'm going to say plus because this is plus this plus is matching that plus. I've got -8i, and then I've got -2i. Remember, the minus has to be distributed to both things. Here, this cleans up to negative 13 minus 10i. Okay, that's addition and subtraction. It's relatively straightforward. Add reals separately from imaginary. Let's do some multiplication. We'll start with a simple one first. We will do 7i times 4 minus 5i. You want to distribute. This is 7i times 4 minus 7i times 5i. This is 28i minus 35i squared. But I squared is negative 1. So this is 28i plus 35. And to put it in standard order, we're going to put the 35 first. 35 plus 28i. Okay. Oh. I rewrite it there since I wrote over it, drawing the next line separator. Now let's kick it up a little notch. Let's do 4 minus 3i times 5 plus 2i. You want to distribute, and it can't hurt to write out everything you're distributing. It takes a little extra writing, but then you're less likely to fuck up. And we don't want to fuck up. No one wants to be a fuck up or make a fuck up. Getting a problem wrong doesn't make you a fuck up. It makes it so you fucked up. So I'm just multiplying the real parts here. And here I've got 3 times 2 is 6, and I times I is I squared. So this is 20 minus 7i minus 6. I squared was negative 1. This is going to turn into a positive 6. We'll add it to the 20. And we've got 26 minus 7i. All right, we're almost done with the complex numbers. There's not a whole lot different to them other than working with the I. If you've been working on your radicals and stuff, you should be good to go. Just adds in another little tiny component. All right, so this is where simplifying matters. Let's do, we hadn't done any radicals yet in it. Let's do square root of negative 7 times square root of negative 14. You need to take out the I first. This is I root 7. We're doing negative 1 times 7 times negative 1 times 14. So this is I root 7 times I root 14. So that was a long way of doing there. We're going to have I squared, and then I'm going to have 7 times 14, and 14 is 7 times 2. This makes it so I've got a 7 squared, and I can pull out a 7. So this is I squared, square root of 7 squared, square root of 2. And I squared is negative 1. So I've got negative 1 times 7 will give me negative 7 square root of 2. Now, if this is the correct answer, the following is wrong. Don't do this. Don't say square root of negative 7 times square root of negative 14. of negative 7 times negative 14 and make it the negatives cancel out in there. This is going to get you 7 root 2 and no negative sign. So we need to take out the I first, because otherwise we get the wrong answer. This is wrong. It's not the right sign. And if you look in Mr. Blakely's textbook, he walks through a similar problem here. He's got negative 5 and negative 10. And if you come down to look at E, where is it? I went past it. Right here, he does the same thing, takes out the I's first. Okay. Finally, we're going to do another problem. Let's do 7 minus the square root of negative 18. Let's just kick this all up a little bit. And then minus 13. I'll put this in parentheses. Square root of negative 98. All right. I'll assume you've paused it and worked on it. If you haven't, you should. This is 7 minus square root of negative 1 times square root of 18, which is 9 times 2. This is minus 13, and then minus square root of negative 1 times 98, which is 49 times 2. This is going to be 7 minus I times 3 root 2 minus 13 minus I times 7 root 2. And we tend to put the I between the whole numbers and the radicals. So this is 7 minus 3I square root of 2 minus 13 minus 7I square root of 2. And these are like terms. I've got an I root 2. I've got an I root 2. They both have the same I. They both got the same radical. We can combine them. We can also combine these two. I get negative 6 and then minus 10I root 2. Okay. I'm actually going to pause the video here and do a third video for 8.6 on complex numbers. We'll be right back. Peace.